Splicing aluminum to copper cables requires careful consideration to avoid violating the National Electrical Code and to ensure a safe and reliable electrical connection. Due to the different properties of these metals, direct splicing can lead to corrosion and connection failures. There are several methods available to splice aluminum to copper cable in a code-compliant manner. Firstly, use a transition connector. These are specifically designed for connecting aluminum to copper cables. Examples include bimetallic connectors, such as HAFAs or CO/ALR connectors, and compression T connectors. It is crucial to follow the manufacturer's instructions for proper installation of these connectors. Secondly, consider a mechanical splice. When using this method, employ mechanical crimp connectors designed for aluminum to copper connections, such as the Bourne DTOL/Cobalt-S series. Again, it is very important to follow the manufacturer's instructions for crimping, ensuring you use the appropriate tool. Thirdly, a compression splice can be used. In this case, use a compression splice kit designed for aluminum to copper connections, such as the Thomas & Betts Aldashku splice kit. Ensure that the compression tool being used is properly rated for both aluminum and copper. As with the other methods, always follow the manufacturer's instructions for proper installation. Beyond selecting the right connector, there are additional requirements to ensure safe and long-lasting splice. Insulation is vital. Utilize heat shrink tubing or other approved insulation over the splice to provide protection and prevent corrosion. Proper insulation is an important safeguard against environmental factors that can degrade the connection over time. Corrosion prevention is equally important. Apply corrosion-resistant compound to the exposed aluminum and copper surfaces before splicing. This will help to minimize the risk of galvanic corrosion, which is a common issue when dissimilar metals are joined. Grounding is also essential. Ground the aluminum and copper conductors in accordance with the National Electrical Code using a separate grounding conductor if necessary. Proper grounding ensures safety and helps to prevent electrical hazards. Finally, inspection is important. It is recommended to have the splice inspected by a qualified electrician to verify proper installation. A professional can identify any potential issues and ensure that the splice meets all applicable codes and standards. It is important to note that splicing aluminum to copper cables is generally not recommended for high-power applications or underground installations due to the increased risk of failure. Always consult the National Electrical Code and local regulations for specific requirements and restrictions. Aluminum and copper have different coefficients of thermal expansion, meaning they expand and contract at different rates with temperature changes. This differential expansion can loosen connections over time, leading to increased resistance, heat generation, and potentially electrical fires. Galvanic corrosion is another significant concern. When aluminum and copper are in direct contact in the presence of an electrolyte, such as moisture, a galvanic cell is formed. The aluminum acts as the anode and corrodes preferentially, weakening the connection. Transition connectors mitigate these issues by providing a bimetallic interface, typically using a material like aluminum alloy bonded to copper. This creates a more stable and corrosion-resistant connection. Mechanical crimp connectors rely on high pressure to create a gas-tight seal between the conductors and the connector. This minimizes the ingress of moisture and other contaminants that can promote corrosion. Compression splice kits utilize similar principles, employing specialized tools to compress the conductors together and create a reliable electrical connection. When selecting connectors, ensure they are listed and labeled for use with both aluminum and copper conductors. Look for markings such as AL/CU or CO/ALR, which indicate that the connector is suitable for connecting these dissimilar metals. Proper preparation of the conductors is crucial for a successful splice. Clean the conductors thoroughly to remove any dirt, grease, or oxidation. Use a wire brush or abrasive pad specifically designed for cleaning electrical conductors. Apply a corrosion inhibitor to the cleaned conductors before making the connection. This will help to prevent future corrosion and ensure a long-lasting splice. When crimping or compressing connectors, use the correct tool and die combination recommended by the manufacturer. Incorrect tooling can result in an improper crimp or compression, leading to a weak or unreliable connection. Follow the manufacturer's instructions carefully for the correct crimping or compression procedure. This typically involves multiple crimps or compressions to ensure a uniform and secure connection. After completing the splice, insulate it thoroughly using heat shrink tubing or other approved insulation. Overlap the insulation onto the existing cable insulation to create a watertight seal. Secure the insulation with electrical tape or other suitable fasteners. Grounding is a critical safety measure that helps to protect against electrical shock and equipment damage. Ensure that the grounding conductor is properly sized and connected to both the aluminum and copper conductors. Follow the National Electrical Code requirements for grounding electrode systems and grounding conductor sizing. Regular inspection and maintenance are essential to ensure the long-term reliability of the splice. Inspect the splice periodically for signs of corrosion, loosening, or damage. Tighten any loose connections and replace any damaged components. Consider using a thermal imaging camera to detect hotspots, which can indicate a problem with the connection. In addition to the methods described above, there are other specialized techniques for splicing aluminum to copper cables. These include welding, brazing, and soldering. However, these methods require specialized equipment and expertise and are not commonly used in general electrical work. Always consult with a qualified electrician before attempting to splice aluminum to copper cables, especially in high power or critical applications. A qualified electrician can assess the specific situation and recommend the most appropriate splicing method and materials. They can also ensure that the splice is performed correctly and meets all applicable codes and standards. It is also prudent to consult with the local authority having jurisdiction, or OJ, regarding approved methods in your area. The NEC provides a comprehensive set of guidelines for electrical installations, but local codes and regulations may have additional requirements or restrictions. Familiarize yourself with these requirements before starting any electrical work. The National Electrical Code Article 110.14 covers electrical connections. This section addresses the requirements for making safe and reliable electrical connections, including those involving dissimilar metals. It emphasizes the importance of using connectors and fittings that are specifically designed and listed for the purpose. The National Electrical Code Article 250 covers grounding and bonding. This article provides detailed requirements for grounding electrical systems and equipment, including the sizing and installation of grounding conductors. It is important to follow these requirements to ensure that the electrical system is properly grounded and protected against electrical faults. The National Electrical Code Article 310 covers conductors for general wiring. This article provides information on the types, sizes, and opacities of conductors used in electrical wiring. It also addresses the requirements for dirting conductors in certain applications, such as when they are installed in raceways or cables. The National Electrical Code Article 408 covers switchboards and panel boards. This article provides requirements for the construction, installation, and wiring of switchboards and panel boards, which are used to distribute electrical power to various circuits. It also addresses the requirements for overcurrent protection and grounding. The National Electrical Code Article 600 covers electric signs and outline lighting. This article provides requirements for the installation and wiring of electric signs and outline lighting, which are commonly used for advertising and decorative purposes. It also addresses the requirements for disconnecting means and overcurrent protection. Remember to always energize the circuit before working on any electrical connections. This is a critical safety precaution that helps to prevent electrical shock and injury. Use a voltage tester to verify that the circuit is de-energized before touching any wires or components. Wear appropriate personal protective equipment, such as safety glasses, gloves, and insulated tools. This will help to protect you from electrical hazards and other potential injuries. Work in a well-lit and ventilated area. This will help you to see what you are doing and avoid breathing in harmful fumes or dust. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. Electricity can be dangerous, and it is always best to err on the side of caution. In summary, splicing aluminum to copper cable requires careful planning, proper materials and adherence to the National Electrical Code. By following the recommendations outlined above, you can create a safe and reliable electrical connection that will last for years to come.